Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about application portability with OneAPI. Today, we have Gretchen Stewart, Chief Data Scientist for Public Sector at Intel with us. Welcome, Gretchen.
Thank you very much. I'm delighted to be here.
Hey, we finally get to have a podcast together. We've been working together for how many years? It's been a while. It's been a couple of years.
The 5.5 since I think I met you the first or second day I started.
Really?
So, yes,
Oh, that's
5.5 years.
Man, I'm feeling old all of a sudden. I've been at Intel a long time all of a sudden. But I think it's great. You're now our Chief Data Scientist for Public Sector. This is going to be the first of many podcasts we're going to do together. But tell us, why are you bringing to the podcast today OneAPI? What is it? What does it bring to the table?
Yeah, well, as always, you have great questions. But thank you for inviting me, and thanks for giving me some time to talk about what is OneAPI. So first, it is honestly an org. So it's oneapi.org. So feel free to go and check it out. The idea is that we really wanted to create, and this is an open standard, to create a unified software environment that is one place that you go to do the development. And then rather than, hey, if I want to use a matrix-based architecture or a scalar architecture or some other type of architecture, you then have to learn a whole nother language, like example CUDA or something else. The idea about this is it's the one place to go. You design your software and then basically you point it to different libraries depending on what it is that you might want to be doing. You recompile and then you run. So as an example, we're working with some folks at the FDA, and they're doing work around crop yields. And they've really been wanting to get more of their product information just in time, as opposed to collecting all that data, then waiting till it gets downloaded and the data ingest process, and 10 days later, they might get the data. You know what I mean?
Right.
And so they were like, hey, could we build something that we could use out in the fields? So leveraging multiple variables around the weather and climate to see about crop yields. And so in the past, they had been doing it on large data centers with large data sets, and they were doing it with GPUs and with Intel's Xeon architecture, the combination. But they were like, we'd like to really see if we could do that out in the field. Could we use Jones? Could we use something else? However, that meant that they were going to have to do a whole translation from the CUDA language to our to some other language. So the truth is, OneAPI kind of came out from all of that in terms of, isn't there an easier way to do this? Do you have to know all 25 different languages? So
it's really abstracted away some of that complexity then?
Exactly.
Oh, okay, and so I only have to learn one language then. That's it. One language.
Exactly.
And then I got it.
It's data parallel programming. So think about it, it's based on C++, but it is an open source C++. So you've got that as a standard, and then multiple kinds of libraries, whether it be like Intel's MKL or a DNN library or other open source, open libraries that are available. And they're all part of this toolkit. And then what we've done is we honestly added, Intel. So Intel took the OneAPI standard, and then we added a couple, I'll call them little side pieces. One of them is a CUDA translator. And that's honestly what the person at the FDA used, and found that that was a way for them to try multiple architectures and multiple products in a way that they didn't have to rewrite their code every time. The translator was probably 85% accurate. I believe it's even more accurate now because ultimately we're announcing this next week at Supercomputing. So the whole product will be available and generally available next week. But So again, it probably is a little bit better, but the idea was that once they did that translation, then they had to do some of their own hard, hard coding, making some of those changes. And then they could try it on a GPU. They could try it on a Xeon at the edge in a small form factor. So there were multiple different products that they could try on the same code that they'd already developed. So
Okay, so
they really love that.
let me dumb this down so I understand, right? Because you're the data scientist. This is really geared towards data processing, right?
Exactly.
And so I can write code once and it will run on processors on our CPUs. It'll run on GPUs. I also heard it's going to run on FPGAs.
It does run on F, correct.
So wow. I mean, because everyone knows programming an FPGA can be very, very difficult, right?
Yep. Yep.
But so you guys have abstracted that away, and I can write a program once and it can run anywhere, but you mentioned I have to recompile it. So it's not write once and compile once and then run anywhere. There's something else in there, right?
It depends on what the libraries are that you're using. So the truth is, if you already know that you're going to use or need an MKL, math kernel library, you have a DNN, there's other libraries, convolutional neural network libraries. If you've connected them to everything and you've compiled it that way, then you're good to go.
Wow.
It's just depending on the architecture itself, there may be some specific libraries that you might want to take advantage of. So there could be a recompile, but there may not
still,
be,
but no rewrite of code.
Exactly. And this is
That's
kind of a
huge.
journey. So it is huge. So think of this as the first step or the first foray into this. And then as you get AI accelerators, so think about Intel that has Habana Labs that we've bought, or other accelerators or AI specific fit for purpose products that we're going to continue, we and others will continue to design. The idea is that this will evolve to give you much more flexibility, and that abstraction will also allow a lot more people to be able to design and code in a way that makes it just easy for people, that it's a simpler way to design, especially from a data science and an AI perspective.
Well, I was just thinking, I mean, Gretchen, I'm a software engineer by trade, right? So that's what I love. I do it in my spare time. I have fun with it. But this is really kind of cool because now I can write something on my laptop. I can try it out there where my laptop's kind of slow, right? I can try it out there. I can then use that same code and run in the cloud, on a fully loaded, a box that's full of neural processors or GPUs or FPGAs. So especially in public sector, right? I'm thinking of those guys that write these special apps that are doing processing on the edge, maybe with an FPGA. I don't have to stand up a full environment in order to do any work. I can do a lot of work just on my laptop and then look at my performance when I'm now running on an FPGA, the same algorithms.
Yeah, and Intel honestly has a developer cloud, which has FPGAs, it has Xeon, it has... The other thing to me that's so fascinating about all of this is that what they're really trying, what we're really trying to do, so again, think of this as a journey, is that once we get the AI and specifically machine learning really built in to this whole OneAPI, it can sniff through the code and say to somebody, hey, this portion of your code, you're going to get the best advantage on a FPGA. This portion of your code would be best on a CPU. And really, as it gets smarter, the idea is that literally you would design and you could have the smarts built in that it would start to say, okay, I'm going to parse your code out to the right places in the architecture that you have currently available to you and have it run faster and perform better and give you your answers in a nanosecond, if you know what I mean. Now,
No,
it's not there yet, but it really is. I mean, that's where it potentially could be. That to me is the most exciting part. The
that is really
abstraction layer
exciting.
feels a little, you know what I mean? The
Yeah.
abstraction layer is I think a really cool part, but think about what you then can do now that we've got the capabilities with AI and machine learning to build that into this software. So then it really helps somebody. I mean, it's not there yet, but think about it.
But yeah,
It's pretty amazing.
that really is amazing, especially when you're talking about optimizing over several distributed systems now, right?
Mhm.
You could decide, am I going to process on the edge, or am I going to semi-process some of it on the edge and move the rest into my data center to do the rest of the processing? That could happen automatically. That would be extraordinary.
Exactly.
So,
Yeah, and you really do think about it, especially because there's so much, I mean, so many people collect so much data, and lots of times there's a lot of it that should just drop on the floor. There's
right.
really no relevance. So think about the fact that you can process things at the edge, get the answer in the data, and have that be actionable. And then there's a certain part of that information that you don't care about anymore, or others that you do that you want to send back to some kind of a data store, a data lake. So you've got that kind of capability to really think about the whole architecture and the data journey from the edge to the cloud in a whole different way when you've got the application made easier for you to take advantage, I think.
No, absolutely. So tell me a little bit about what is in OneAPI as far as libraries and things that I can take advantage of. Because there's a lot of
Got it.
AI frameworks that are out there, right?
Yep, yep. Well, first, as you said, it simplifies any kind of code migration from something proprietary to an open source programming language. So the starting point is based on SYCL, which is SYCL, and it's been developed under a whole industry consortium called Kronos Group. So we're basing it on an open standard. So you've got that as kind of the development framework. And then you have, and literally, I do not have a list. So it's part of some of the pointers, but it's got neural network libraries. It's got MKL, so math kernel libraries. It's got libraries for neural networks. It's got libraries for machine learning. It's got other algorithms that are built in. There's like a list of, I want to say 20 or 30 at least, if not more, libraries that you can take advantage of. So, machine to machine kind of information. If you're doing some matrix math, it's got things that you would think of as neural network kind of libraries, et cetera, that are all built into it that you can take advantage of. And they're all open. So OpenCNN or OpenDNN, et cetera. So these are things that are all part of the larger consortium to be able to be used. And yes, there's a bunch of our libraries and things like that we've made available open source that you can just go out to GitHub and get that. Oh, by the way, that's where you can get this. You just go to GitHub and you can get the OneAPI application with all of the libraries.
Very cool. Now, another question I know people are going to ask, or they're going to make a comment. Darren, I've already spent time and money into make TensorFlow, for example, right? Can TensorFlow take advantage of OneAPI so that my TensorFlows that I've already established, they can run in OneAPI, and then that opens it up to run on different types of hardware for me? Has that happened yet, or is there plans for that? Do you know?
There's definitely plans, because TensorFlow is a framework. And so, you build things like BERT, as an example, is some work that people have done off of TensorFlow. And so one of the things that Intel's done as we're thinking about OneAPI is we've optimized TensorFlow. So anybody who builds off of the optimized TensorFlow gets those advantages already. And then the idea is that the TensorFlow libraries and the framework are all slowly but surely being added into this, I'll call it OneAPI programming nirvana. So the idea is for a lot of those frameworks that if they're in many cases already optimized by Intel, and then they're just being incorporated, or they're using the same libraries, so it has easy conversion, and you're able to use it, or you're able to add on or build onto it.
Oh, very nice. Okay. Where do I find out more information? You mentioned already GitHub. You mentioned
Yes.
OneAPI.org, right?
OneAPI.org, intel.software.com. There's information for you to sign up. It's really easy. I've done it. Put your name, a little bit of info, and you get access for 120 days. And it will ask you again at the 120 days, do you want to still have access to get access to the Dev Cloud? So, which has the FPGAs and Xeon and a number of different architectures. So really, the idea is, we know as things continue to move forward, there's more and more architectures that have been designed or will be designed. So there's scalar, there's matrix, there's vector. We're just going to continue to see more and more of those. And so if we continue to leverage some kind of standard software and then add additional libraries, then again, everything is reusable and portable. And for you and me who've done software for a long time, wouldn't that have been really cool when I was dealing with file systems and swap space and all that kind of stuff? And it's like, oh, if I didn't have to rewrite everything, that would have been really nice.
Yeah, no, this is very cool stuff. Hey, Gretchen, thank you very much. I'm sure we're going to hear a lot more about OneAPI over the course of the next couple of years. It's right at the beginning.
Next week, it's generally available, and it's going to be the highlight of some of the things that we talk about when Supercomputing Virtual happens next week.
So that's November 10th, 11th?
10th, 11th, 12th, I think. It's like 2 or 3 days.
Okay, that's awesome. All right.
Yeah.
Thanks,
So
Gretchen.
thank you.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.